Welcome to Werks. I hope you enjoyed today's video, and if you do, please like, subscribe, and comment. Today's video shows the Tangent Engineering Quill Wheel adapter I made to fit the quill wheel to my Grizzly Go759 mill. I made the adapter from 6061 aluminum instead of steel because I didn't have a good way to cut the internal keyway from steel, and I could cut the keyway from aluminum with a very basic but janky setup in the lathe. You will notice as I cut the keyway, the chuck will rotate very slightly. I would have rather made it from steel and may remake it out of steel if the aluminum adapter doesn't hold up. I really like the quill wheel, but I need to use it for a while to figure out how best to use it on the small mill. The Tangent Engineering Wheel was supplied to me by Jim, and he only asked for a picture of it installed on the Grizzly Go759. I can see a few more projects coming in the future as a result of making this video, like a way of locking the chuck in place, making a keyway cutter for the lathe and mill, and a future video on a modification to make the Tangent Engineering Quill Wheel a little easier to use. The first thing I needed to do was cut a blank from some aluminum round stock. I used my Evolution 380 cold cut saw to cut the blank. This saw is a beast. Cuts fast, no heat, no smells, and the blank was almost burr free. I've mounted the saw on a Hercules miter stand, which I really like. I can fold the stand up and wheel it around like a two-wheeler, store it in an out-of-way space, which helps saving space in the shop.
Software solutions, but they work at a small scale. As you go larger in scale and you have to support thousands and thousands of customers, then you do need.
It may look like I'm applying a lot of pressure to the saw to get it to cut, but I am not. The only fault with this setup is the mess it makes as it cuts. I deburred the blank and set it up in the Grizzly Go768 lathe 3-jaw chuck. I faced the end of the blank to clean it up and then deburred the blank using a mill file. I removed the blank from the chuck and flipped the blank end for end and then remounted the blank back into the chuck and faced the end of the blank. I measured the blank and cut it down for an overall length. Remember, measure twice, cut once, because it's really easy to remove stock but very difficult to add it back on later. I decided to get the Tangent Engineering burnishing tool out and try it on aluminum blank and see what it would do on aluminum. I did the usual setup, placed a finger on the bearing and touched off on the workpiece until the bearing rotated. Then I removed my finger from the bearing, backed the tool off towards the front of the blank. I added a few thousandths to the cross slide and ran the tool across the face of the blank. I then moved the tool off the front of the blank and added a few more thousandths to the cross slide and repeated the process. If you look closely, you can see an almost mirror-like finish and the face is glass smooth. The burnishing on the face wasn't needed, but I wanted to get some more experience using the tool. I used the 5/6" center drill to drill the blank face. After I center drilled the blank, I started to drill the main body of the blank. Be sure you clean the chips and cuttings from the work to avoid any safety issues that would happen if they get caught up in the chuck or work piece. Be careful and use pliers instead of bare hands like I did. The chips and cuttings are very sharp, almost like razor blades. After cleaning the chips and cuttings from the workpiece, chuck, and drill chuck, I continued the drilling operation. I was getting a little chatter and adjusted the speed of the lathe a few times to correct far and eliminate the chatter. I finally got the speed correct and went all out drilling the main body. This is what happens when you don't clean the chips and cuttings frequently. Whirling razor blades. I used the largest drill I had and still needed a bigger diameter on the bore of the main body of the blank. I set up and touched off on the side of the hole, and then I started to bore the hole to get the correct size. Once I got the bore to the correct size, I turned the compound to the correct angle that I needed for the taper that was required for the fine adjustment locking feature to work on the Grizzly mill. I also locked the carriage in place so that I could hold the position for the boring operation. I was getting a really good finish on the cut and I was happy with the finish. I would dial in the compound, then dial it back out to remove the boring bar from the bore. I would back out the cross slide to add further engagement of the tool in the bore, dial in the cross slide, dial out the cross slide, dial out the compound to add more engagement of the tool, and repeat until the boring operation was finished. Here's a view of the finished bore, and hopefully you can see how good the finish was on the blank. Now I'm showing the janky setup for the cutting of the internal keyway. It worked, but it could have been better with the right tools in the setup. You use what you got. I speeded up the video in order to show that if you look closely, you can see the chuck rotate a very small amount. I need a way to lock the chuck in place to keep it from rotating. I then use the red Sharpie to ink up the blank and face the end to length, and will turn the blank to the needed diameter. There is something about turning a part that's inked up and cutting the ink off that I find pleasing. I'm still learning this lathe and its capabilities, and you can see me taking heavier cuts as I turn the blank down. Oh, and remember the safety warning. Clean your chips and cuttings to avoid the whirling razor blades. I'm checking the fit of the quill wheel bushing to my adapter. I don't want a press fit, just a loose fit. There are ways of tightening a hole a bit if needed. If you want to know how to tighten a hole, leave a comment requesting that info, and I'll let you know. I have removed the blank from the chuck and turned it in for end and put it back into the chuck. I'm turning the end down to match the diameter of the turn portion of the blank. I'm really hogging off material to learn the limits of the lathe. Once I'm really close, I start to use my fingers to get the diameter spot on. I can feel a ridge of a thousandth or two after spending some time in a machine shop and doing this process. Now that all the turning work is done on the blank, I clamp it in the vise on the mill to cut the outside keyway. Pretty straightforward process. I should have used the V-block to hold the adapter in place, but I felt it would stay put the way I had it clamped in the vise. That's a big gamble, because if it didn't hold the adapter and it moved, I might have to start all over again. Here are a couple views of the adapter on the turntable. I also show views of the parts that are used to attach the quill wheel to the Grizzly mill. I'm starting to attach the quill wheel to the Grizzly mill. I first place the adapter on the gear shaft of the fine adjustment. It's a little bit of a tight fit, but over time will loosen up as it is removed and replaced on the shaft. It was a little bit tighter than I wanted, but that is due to the chuck turning as the keyway was cut. Next, I place the knob bolt through the quill hub and place the spring over it. I almost forgot to put the keyway in. I placed the hub with the knob bolt and spring onto the gear shaft, which is easier said than done. Once in place, I tighten the knob bolt to secure all items on the gear shaft. I then placed the quill wheel onto the hub and determined the position I wanted it. I thought having the biggest opening between the spokes at a 45-degree angle to the head might work well and can be changed later if wanted. I then proceeded to line and tighten the screws to secure the quill wheel to the quill hub. Finished, well, kind of. I'm now using the quill wheel to move the quill up and down, and then fully tighten the knob bolt to engage the fine feed, and use the fine feed knob to move the quill up and down. I hope you enjoyed the video as much as I did making it. If you did, please like, subscribe, and comment.
Thank you for watching Werks, and I hope you enjoyed the video. If you did like the video, please give a thumbs up, subscribe for future videos, and comment. Thanks again.